Okay, ladies and gentlemen, this video is a review on factoring. So look at problem 12 here on this worksheet. And I'm just going to be very straightforward. Notice the number 15 and 6. What number can I divide 15 and 6 by? Well, aren't they both part of the 3 times tables? So I'm going to use a 3. Okay? And now look at the b squared and the b. Does everybody agree b squared is b times b? So they both have a b inside of them as well. And what we have right here, guys, that 3b is what we call our greatest common factor. Okay? And so this is a polynomial expression that we are going to factor using GCF. So redoing it again a little bit, does everybody agree my GCF is 3b? So what do we have left then? If I factor out a 3b, does everybody agree 15b squared is really 3b, look what I'm doing here, times 5b. Again, 3 times 5, 15, b times b, voila, I have 15b squared. Likewise, if I went ahead and did a plus 2, isn't 3b here times the 2 6b? Yes, it is 6b. So just cleaning it up here a little bit, when all is said and done, 15b squared, this expression right here, plus 6b, right here, is factored into simply 3b times 5b plus 2 in parentheses. Okay, so pause the video and make sure you have that in your notes. So let's take a look at another one that may even be simpler. Notice the 70 and the 30. I know they're part of my 10 times tables, right? And then notice this has an x. Uh-oh, there's no x over there, is there? So guess what? My GCF is just simply 10. And so, continuing with division or multiplying backwards, does everybody agree 10 times 7x is 70x? And of course, 10 times 3 is that 30 right there. Think about it. So in other words, 10 times 7x plus 3 is the factored form of the original expression. And again, you can always check by multiplying through, right? You could do 10 times 7x, 70x. 10 times 3, 30. So does everybody agree I get this 70x and this 30 back to me when I do the distributive property? So another way to think about it is GCF factoring is simply distributive property backwards. So pause the video if you need to. Okay, now notice this one's a different problem. I have an n squared, a n, and a minus 20, and think about it. Do they have anything in common? And the answer is no. But if you recall from multiplying or using distributive property in the previous video, you should realize, wait a minute, this expression with these 3 terms, 1, 2, 3 terms like that, is always a result of 2 parentheses, 2 binomials multiplied together, correct? Okay, so let me clean this up. We're going to start from scratch. So getting straight to my point, I know n times n is n squared. I know 4 times 5 is the 20. Now we got to watch out for that little negative there. We got to make sure that works, okay? Now look at what we have in the middle. See that plus n? Well, if you look at what we have so far, the 4 times the n is 4n, right? And the 5 times that n is 5n. Can I get a plus 1n with a 5 and a 4 in? And the answer is, if I do plus 5 minus 4, is that not the 1 in? Well, of course it is. So, therefore, all I need to finish this up is a minus 4 and a plus 5. And also notice negative 4 times positive 5, is negative 20 as well. So I have n squared covered with n times n. I have the plus 1n covered with the 5n minus 4n. And I have that negative 20 right there covered with negative 4 times positive 5, correct? So in the end, my result is just simply n minus 4 again times n plus 5. This is, again, what we call the factored form, okay, of what we started with right there. Okay, so pause the video and make sure you understand the difference between this problem and the previous two problems where we did a GCF. Alright, let's just do one more that's a little bit tougher. Notice this one has a 2n squared in front. So ask yourself, how can I multiply two terms and get a 2n squared? And the most common way is 2n times n, correct? Notice I'm using two parentheses because I have 1, 2, 3 terms again, right? And so that's one thing to always look for. So we have the 2n squared covered. What about this 9 over here? Well, 9 most commonly is 3 times 3, right? So let's see what we have going on here. This 3 will times n and give me 3n. This 3 will times a 2 and give me 6n. Uh-oh. Did you guys realize 6 and 3 cannot make minus 7? What can I do then? I know 3 times 3 logically does not work anymore, right? So how about if we try 9 times 1? And right here, of course, I get 9n. And the 1 times 2n is 2n. I can get minus 7 now if I do plus 2 minus 9, right? So I'm just going to put a minus there because that's going to give me this minus 9. And I'm going to put a plus there because plus 1 times with the 2 there will give me that plus 2n. And finally, notice negative 9 times negative 1, of course, is negative 9. So when all is said and done, guys, 2n minus 9 times n plus 1 is the factored form of this problem. So please pause the video again if you need to and watch it again. I'm telling you right now, this skill is so vital to your success the rest of your high school career. You must be very proficient at factoring. So I'll leave you with that final thought, and I'll see you in class next time. Bye.